Dear students, in this video, I am going to continue the next part of strength of organic acids and bases. In this video, what are the different factors are responsible for the strength of HA bond? What are the different factors responsible for the acidity of compound? So the first factor in this, the strength of HA bond. The second factor is electronegativity of A. Third, factor stabilizing A compared to HA and the nature of the nature of the solvent. So these 4 points I'm going to discuss in this video. Now, let us take first example. That 3 different molecules are there. That is, first molecule is pK, second methanol, third is methanoic acid. Now the pK values are given 43, nearly about 43. This is 16 and this one is 3.7. So each one, this is denoted by compound A, this is compound B, and this is compound C. So you will get the idea from the pK value that pK value go on decreasing from methane to methanoic acid. So from the pK value, what we conclude that as the pK value goes on decreasing from A to C, indicate that the acidity go on increasing from A to C. So that we already discussed what is the relation between the pK value and the acidity. Now look at the as we are talking about it is an acid. So what is acid? Acid donates its H plus ion. So the methane dissociate as CH3 minus H plus, methanol dissociate as methoxy plus H plus, and methanoic acid dissociate as methanoate plus H plus. Now after this dissociation, there is a negative charge on methyl group, that is a anion which is formed, that is called as a conjugate base. Now what is the difference? What are the differences you can see among the 3 molecules? Here this hydrogen is attached to carbon, hydrogen attached to oxygen. Here hydrogen is again attached to oxygen. So difference over here in these 3 molecules, that is hydrogen attached to carbon, oxygen and oxygen. Now what is the difference between the electronegativity of carbon and oxygen? Carbon is less electronegative as compared to oxygen, while oxygen is more electronegative as compared to carbon. So because of this electronegativity, a carbon cannot carry a negative charge very well as compared to oxygen. So because of this conjugate base is less stable as compared to this, If this conjugate base is less stable, so what we have to conclude? This dissociation is difficult. If this dissociation is difficult, indicate this hydrogen-carbon bond is strong, right? If this bond is strong, then it shows very, very slow dissociation. Therefore, it is a weak acid. Hence, larger pK value, weaker is the acid. Now, what is the difference in case of the B compound? As the oxygen carry negative charge, so compared with A, the methoxy group or the methoxy conjugate base is more stable as compared to CH3 minus. Due to that, what we had to say here, this conjugate base is as it is more stable, so compared to A, this dissociation is fast. If this dissociation is fast, indicate HO bond is weak as compared to A, right? So if this bond is weak as compared to A, indicate as compared to A, this dissociation is fast. So same is written over here. This dissociation is fast. So what we have to conclude here now? If this dissociation fast means as compared to A, this is a strong acid, right? So that we can conclude from the pK value that 43 changes to 16. But now what happens in case of a methanoic acid or formic acid? The pK value still decreases to 3.7. indicating this is a strong acid as compared to methanol. Now, what is the reason behind it? After the dissociation of H plus ions, so whatever the methanoid ion is generated, that methanoid ion gets stabilized by this type of a resonance. So O minus go back to this, forms a double bond here, and this double bond changes to this single bond. So because of this resonating structure, what we have to say over here, that this conjugate base is stable. The reason this conjugate base, not only the oxygen carry the negative charge, but as well as there is a delocalization of the negative charge. So oxygen, either this oxygen carry a negative charge or this oxygen carry a negative charge. So the charge distribution is there. If there is a charge distribution or charge delocalization is there, then that structure is always a stable. So because of that, as compared to structure B, the methoxy conjugate base and the methanoid conjugate base, the more stable structure is, the more stable conjugate base is methanoid. The reason, not only the oxygen carry the negative charge, but as well as there is a presence of electron withdrawing resonance effect. So this conjugate base is stabilized because of what? That oxygen carry a negative charge, that is more electronegative atom carry a negative charge, as well as this negative charge is stabilized by the electron withdrawing resonance effect shown by this oxygen. Because of that, if this conjugate base is highly stable, indicate what? This reaction is more towards the forward side. So because of that, the next statement is what? That this dissociation is fast. If this dissociation is fast, indicate what? This oxygen hydrogen bond is very, very weak. That's why it dissociate readily. If this dissociate readily, then what we had to say? This has to be a strong acid. If it is a strong acid, then next is what? It should have a small pK value. So carbonyl group, the role of the carbonyl group, this role of the carbonyl group is what? It shows a electron withdrawing resonance effect, and that is responsible for the stability of the conjugate base. So because of that, it increases the acidity of the structure. So when we compare between the methane, methanol and methanoic acid, so which factors we discuss under this example? That first is strength, that is the electronegativity of E. So carbon, oxygen, oxygen, that is the electronegativity of E. What is the second factor we discuss? That is the, what is the strength of the HA bond. So here the strength of HA bond is what? Strong as compared to this, as compared to this. So among three, the strength of HA bond is very, very weak in the methanoic acid. So that is the second thing that we discussed. What is the third factor? Third factor is the factors responsible for the stability of A. So what is the A? A is the conjugate base. Which factors are responsible for the stability of A? So here the minus R group is responsible for the stability of A. So all these three factors are responsible for the acidity of the structures. Now the next example, that is alcohols are less acidic as compared to carboxylic acid. Let us take an example, that is first example is methanol and the second example is the same, just now we discussed is methanoic acid. Now in methanol, you can see after the dissociation that this proton undergoing a dissociation, because of that, what you can see, which conjugate base is forming, that is CH3 CH2O minus and H3O plus. So this conjugate base, that oxygen carry a negative charge. Same after dissociation of this, which group carry a negative charge? Again oxygen carry a negative charge. So here and here what we have to say, both in both the case that oxygen carry the negative charge. But what is the next feature we can see over here? The next feature is that this CH3CH2 group is a electron donating group. So because of that, it shows a plus I effect. So plus I effect, what is the role of plus I effect? That ethyl group donate its electron density to oxygen. Because of that, what happens? The oxygen having more electron density. So if it has a more electron density, and there is no factor for the delocalization of this negative charge, because of that we call this is a localization of charge. Localization of charge, because of the localization of the charge, the already oxygen is negative, and again ethyl group is donating its electron density to this oxygen, so charge is localized. Whenever a localized charge is there, that is always unstable situation. Because of that, plus I effect shown by the ethyl group destabilize the conjugate base. But what happened in the next case? That is not possible in this case. That is here, that is a carbonyl. Because of the presence of carbonyl group, it, that is we call it is an electron withdrawing resonance effect shown by the carbonyl group. There is a distribution of negative charge from one oxygen to another oxygen. We call it is a delocalization of the charge. Because of the delocalization of charge, the structure becomes more stable. So this conjugate base is less stable as compared to this conjugate base. So the stability of the conjugate base is more important, and which factor is responsible here? Here the minus R effect shown by the carbonyl group is more important, which stabilizes the negative charge by delocalization. But in this case, as there is no resonance, instead of that, which factor is present here? A electron donating inductive effect is there, which destabilize the conjugate base due to the localization of the charge. Because of that, as this conjugate base is less stable, so what is the next? The dissociation is difficult. Why the dissociation is difficult? That means oxygen hydrogen bond is strong. That's why dissociation is difficult. If the dissociation is difficult, means it is a weak acid as compared to this. If this conjugate base is more stable, indicate what? This dissociation easy. When this dissociation is easy, if oxygen hydrogen bond is weak. If this bond is weak, indicate what? There is a strong dissociation, or in other words, we call it is a strong acid. So alcohols are less acidic than carboxylic acids. The same is given over here. Now here, instead of formic acid, the acid is now acid, that is the acetic acid or ethanoic acid. So the pK value of this is 4.76, while ethanol is pK value is 16. So from the pK value, what we conclude, that ethanol is a weaker acid, while acetic acid is a stronger acid. The same statement over here, after the dissociation of this, that negative charge, whatever the negative charge is generated on this oxygen, that can be stabilized by this way. That is the resonance stabilization, or we call it is a electron withdrawing resonance effect shown by the carbonyl group. Because of that, the conjugate base which is generated from the acetic acid, that is more stable as compared to this. But in this case, there is a localization of charge due to what? Due to the ethyl group, which is a that is showing a electron donating inductive effect. So because of this, the negative charge in acetate ion is evenly distributed over the two oxygen, while the negative charge is localized on its oxygen in epoxide anion. Just now we discussed this thing. So because of this conjugate base is more stable. If the conjugate base is more stable, then dissociation is fast. If the fast dissociation is there, indicate the strength of HA bond is weak. If the strength of HA bond is weak, then what we have to conclude, that this has to be a strong acid as compared to this. In this example, That is what we are going to consider, that is phenols are more acidic than alcohols. Now take the example for this. Phenol, the pK value for this is 9.9, and this is ethanol, the pK value is 16. So 9.9 pK value and 16 pK value, again you can see, so that is larger the pK value, weaker is the acid. So ethanol is a weak acid as compared to the phenol. Now you can see here, after the dissociation of this phenol proton, it gives you a phenoxide ion and H plus. Now what happened in case of a phenoxide ion? The resonance, you can see so many resonating structures are possible for the stabilization of conjugate base. So whatever the negative charge is generated, that negative charge is delocalized in the ring. So if there is a negative charge, first delocalization structure. After this, again, this charge is forming a double bond here, and new negative charge on this carbon, and so on. So we can draw the resonating structure for this phenoxide ion. But here, the negative charge which is present on the oxygen, now it get transferred towards the carbon. But again, what we had to say, as the negative charge is transferred towards the aromatic ring, so we call it is the conjugate base stabilized due to the resonance. No such stabilization in alcohols. So in alcohols that we already discussed, instead of resonance, there is a electron donating inductive effect. Because of that, there is a localization of the charge. Hence, this conjugate base is less stable as compared to an oxide ion. So due to this, as the conjugate base is less stable, indicate the dissociation is low. Why the dissociation is low? Because the strength of oxygen-hydrogen bond is strong as compared to oxygen-hydrogen bond in phenol. Due to this, phenols are more acidic as compared to the alcohols. The next example is phenols are weaker acids than the carboxylic acids. The example under this, that is the acetic acid, ethanoic acid, and the phenol. The pK value of phenol is 9.9 and acetic acid is 4.76. So from the pK value, what we conclude that acetic acid having a smaller pK value, so it has to be a stronger acid as compared to phenol. Now, the dissociation of phenol that we already discussed, how we can stabilize the negative charge which is present on the oxygen by the way of a resonance, that also we already discussed. Now acetic acid, after the dissociation, it gives acetate ion and H plus ion, and then the stabilization of the conjugate base O minus transfer its electron density to this next oxygen. Because of that, what happens, they negative charge either on this oxygen or it can be on this oxygen. Now what is the difference? As this is more acidic, indicating what? This conjugate base is more stable. Now, what are the reasons for the more stability of this conjugate base? That is the acetate ion. Now, you can see here, due to the resonance in both the structure, there is a resonance. But in this structure, what you can see, the oxygen, due to the resonance, initially there is a negative charge on oxygen. After the resonance, again the negative charge on this oxygen. So, in this resonance, every time oxygen carry a negative charge. But what you can see the difference here, due to resonating structure, the carbon carry a negative charge along with the oxygen. So which two atoms share the negative charge? Oxygen and carbon. Here both the oxygen share the negative charge. And as we already discussed, carbon is less electronegative, therefore it cannot bear a negative charge very well as compared to oxygen. So this resonance is more effective as compared to this resonance. So how we can explain this? The resonance possible, that is the electron withdrawing resonance shown by the carbonyl group, is more effective as compared to the resonance observed in case of that resonance due to the aromatic ring. Because of that, this dissociation is fast. If this dissociation is fast, indicate oxygen hydrogen bond is weak as compared to phenol. If this oxygen hydrogen bond is weak as compared to phenol, means it easily undergo dissociation. If it easily undergo dissociation, indicate what? It has to be a strong acid as compared to phenol. So phenols are weaker acid than the carboxylic acids. So same is written over here. Larger the pK, weaker is the acid. Exactly opposite statement here. Smaller the pK, stronger is the acid. It indicate conjugate base is less stable. This indicate conjugate base is more stable. That what is the indication of that? That is the absence of electron withdrawing effect. Here indicate presence of electron withdrawing effect. Or that is the another option, or the presence of electron donating effect. So acidity is responsible with the two effects. The acidity increases when there is a electron withdrawing group present. Acidity decreases if there is a presence of electron donating group. So conjugate base phenoxide is less stable. In resonating structure, the carbon bear the negative charge, which is less electronegative than oxygen. But in case of resonating structure of phenoxide, the negative acetate ion, the negative charge is present on the here. In case of acetate, the negative charge is present on what? It is present on, instead of it is phenoxide, the negative charge is present on oxygen. So here it is present on oxygen, that is in case of a acetate group. So you make it correction, there is a negative charge present in case of a acetate ion. So strength of HA bond is weak over here, hence it dissociate fast. Therefore, it is a strong acid as compared to this. So acetic acid is strong acid as compared to phenol. Now, what is the influence of the solvent on the acidity? This is the acid. In presence of water, what you see, there is a protonation, or we can call it is a protonated water. And what is another role? Whatever the conjugate base is generated, that is A minus, that is stabilized by the such type of a solvation. We call it is a solvation, that is a A minus, that OH and H is a polarized bond. So hydrogen is having a partial plus sign, and this hydroxy group is there is a partial minus. So what type of bonding it is? This one is negative and this positive. So we call it is this type of bonding, that is a solvent, and conjugate base, this we call it is a solvolysis. So this is called as a solvolysis. Because of this solvolysis, what happens? It gives the stability to the conjugate base. Now the conjugate base is more stable because of there is a positive negative interaction between the solvent and conjugate base. So due to solvolysis, the conjugate that increases the stability of conjugate base. And just now we discussed, if you increase the stability of the conjugate base, then this reaction is towards the forward direction. So in other words, what we have to say, because of the solvent, if the solvent is polarized solvent, then there is such type of a solvolysis possible. Because of that, what we have to say, the polar solvent increases the acidity of the compound. So, in other words, now look at in the HCl is strongly acidic in water. The reason behind it, that Cl minus again stabilizes, stabilizing like this due to solvolysis. But what happens in case of a toluene? So toluene is what? It's a non-polar solvent. So non-polar solvent is there. If non-polar solvent is there, then Cl minus cannot be stabilized because of the such solvolysis process, that is positive negative interactions are absent. So because of this, what he had to say, in presence of toluene, the HCl remains undissociated. So in non-polar solvent, the hydrochloric acid is weakly acidic, while in polar solvent, this is a strong acid. So influence of the solvent is important. If the solvent is polar, it increases the acidity of the compound. If the solvent is less polar or non-polar, then automatically it decreases the acidity of the compound. And how it increases the acidity of compound? In presence of a polar solvent. In presence of polar solvent, such type of a solvolysis can be possible due to positive negative interaction. So because of that, this conjugate base is more stable. So polar solvent always increases the acidity of the compound. So for this, you refer the book.